want to begin the troubleshooting of the booster tank element. First, you need to switch to the ohms on your meter. Then begin to remove the terminals. I'm going to remove virtually all the whole terminal to give room for. But before then, let me check if there's any voltage present on the machine. Let me check any voltage present. There's no voltage. There's no voltage. There's no voltage. So you have to be very sure that there's no voltage on the terminal of the element before you begin any kind of work or form of troubleshooting. So I'll be changing it back to ohms. Then the next thing is for you to remove all the terminals. Be sure you can leave the earth cables. These are loops. I have to remove all of them. Because after troubleshooting, I'll still need to replace the element. I'm removing them one after the other. Remove them. Keep them aside. Remove. These are the loops. The reason why you need to remove the loops is to pave way for clear troubleshooting on the element terminals. I'm still removing. So this is the main hard supply. Remove. Loose cylinders. There's a contact here. Which I need to remove. Yeah. See? Do this one. You can bring this one out. This is the main supply of the booster tank. Then replace this back so that in the course of reassembly to be easy for you to access. So these are the elements. I have 1, 2, 3, 4, and each one of them is rated 4,880 watts. So this terminal will have to reach to this. So I put one here, put one here. You can see there's no reading on the element. This shows that the element is dead. This particular element is dead. So I'm going to read the second one again. Put again. Place it again. You see this one is dead. This is to confirm that this element is completely dead. So I'm going to test this other one. This other one against this. This is dead. This one is dead as well. So I'm moving it here again. Let me move it here and test with this again. You can see this one is dead. So this is to confirm that this element and this other element are dead. So now let me check this other one and see if there's any reading. You can see this one is dead as well. This one, let's go to the next one. Okay. Only one is reading here. So only one is reading here. Now let me see again. Let me read this other one against. You can see this one is also reading. Let's check the second one. And it's also reading. It's reading, so which means this element, this particular one is okay. It's okay. Why only one is working here? That's the internal. The internal element is the one working. The outer element is dead. This one is dead. This one is dead. So out of 4,880 watts, so divide by 2, you have 2,400 and something. 440. 440 is 2,440 watts produced only by this element. Why this one is still giving us the required heating capacity. So as soon as the new element comes, we'll be removing this and replacing them. And in the course of replacement, you have to make sure that it is well connected. Well connected. You have face here. You have face here. You have face here. Then here and these are looped. Face here, face here. This one is looped to this and this. You have your face here. You have your face here. This and this is looped to this. This one, face here and face here. This, all the white part of it are looped together. They are looped together so as to form a star, connection. So each, you can see the element here. I think each one of them is rated 3 kilowatts. So and this booster tank is rated 15 kilowatts. So each of the elements is not supposed to be more than 3 kilowatts. So this is just a plug. Additionally, you can also put additional element here to make it 5. If you are using 3 kilowatts, you can put additional element here to make it 3. But in Hobart element, you can't get exactly 3 kilowatts. You have, I think the one that is available is around 2,000 plus. It's not even up to 3 kilowatts. So you have 2,000 plus, 2,000 plus, 2,000 plus, 2,000 plus, 2,000 plus. It's approximately 15 kilowatts. So I'm awaiting the new elements so that we can replace them and get this machine, get this booster running properly. This is the major problem of the machine. Secondly, we are going to replace the probe, temperature probe. It's an NTC temperature probe. Thank you. Now this is a new element, as you can see. Now see, this is rated 4,880 watts, 254 volts. This is a new one. This is also another new one. So I'll be using it to replace. This and this, so as to get the machine running. I'm going to lose this one. Don't worry. Try to lose this one so that you can see, you allow the water. You see, you can see water flowing out of it. So normally you are supposed to open the base. You understand? It has a cover under. So you need to open it to allow the water to flow out. So, but since we are changing this one now, I will allow the water to flow out slightly because of the pressure inside this place. If you are dealing with a booster tank like this, always ensure that the booster tank cools down. You understand? To room temperature before you attempt opening it. Because if you open it as it is and it's under pressure, then anything that happens, it means you are the one that is at fault. So always make sure that you take safety very, very serious. Very, very serious, because the pressure on this is always very, very high when it's hot. So but as it is now, it's very, very cold. It's at room temperature. You get it. So you are still very okay. So you open, you loose, loose. You see? I'm going to lose that nut. You lose it almost, let it be. Don't worry. You don't need to use your hand. I'm not losing it out. You understand? So you see how it is now. And you are going to press this one in. You can see that this one is in now. So you can now pull out with ease. You can see the pressure of the water that is coming out. You see? So you allow the water to flow out. So you can see this is just normal, room temperature, water. Assuming this one is pressurized, what do you think will happen? As you are attempting pulling it out, what will happen? The pressure will force it out, and you can injure yourself. If you loosen this knot and you don't push it in, you understand, it will not release. That is why somebody who is not very experienced, if you try to pull it out, there's tendency for you to injure this space. When you injure this space, by the time you put the new one, what happens? It begins to leak. So you remove it, and see this one is completely out. Okay. Give me another one. I'm only going to put one. I don't want us to put. So this one now, let's do our calculation. This one is 4,800. 4,800 divided by 2 is what? How many kilowatts?
4,000 divided by 2.
Yeah, 4,880.
That is
2,440.
Yeah.
2,440.
Yeah.
Isn't it? Plus 4,880. That's almost approximately 7,000. That's half of the tank. So let's use this, because why I want us to use this, we don't have enough. We don't have enough element. Okay. See, I'm doing the wrong thing. We lose this. First of all, loosen this. Always make sure you lose this first. Now knock this out. So now you need to push this one inside first. You see it's inside now. You can see, look at it. This one is inside now, this one is inside. So before you now push in, you can see it's very firm now. So somebody should come and tie it. Tie it like this. see it's very firm now. So what we need to do now, we have between these two now, we have what? We have 7,000, all 7,000 plus these two. This one, we have to read this one to add to be sure if this one we look to this. Let's look to this. Let's look this one to this. Understand? Let's take another look again. Look this one to this. See it? The many one look now. Look this one. For this. I said the loop is complete now. And the next is for us to loop the. I went to loop the. Let's first of all connect the arc. Let's connect the X. This one is here. Let's connect this one to. Let me put that for that. Let's connect this one to this X. Are we correct? Let's see. We're not correct. This one is not working. This one is not working. So let's connect it to this one. And before we now place this, so we can put this one on it. So
that thing when we carry that time, you see they there. Like say see they there.
better than that. What?
The engineer. Okay.
How was your training?
Fine, man.
So let's try this one. So this is whether is having headache or what?
No, they. When something see you like this, it's covered. So.
Okay, so we connect this one. Let's connect this one. It's covered. This is one face. This is another face. This is another face.
The element is not connected.
It's connected already, so
We change
we change it. So let's connect this one. And this one to this. Let me use the upper one. No, you can go now. Okay. So let's use this.
I don't finish.
Yeah. We are done. We are done. We are done.
Okay. That scan box.
Let this. Let me.
I don't put another one. It's working. I mean, they bring that, but it's not. When I do that, it's covered in one of the terminals for the element. Don't go. I asked pressure to connect it. When I come, I say connect and yet no ready.
Under this one. So remaining this face. So this face
And
now.
this cheap restaurant issue. I see say they bring it, I did the element don't come now.
Yes, now they signed one yesterday now.
The small brand. Because when I was coming from training, this Sonny said make them go carry element from store. Lo and behold, the element when they carry now for the black pan. You understand me?
Yes.
So it's like the element don't do.
I was.
Get chance to go and
I
find.
received
Get
six.
chance, maybe tomorrow.
This one is not making. Use plier to creep this one. It's my meter.
So this was your own?
Yes, sir.
Okay, this is now got you.
So what you happen? Where you want carry and go? So this. Make sure it's making contact. So that is it. You see the connection.
So this is the prop for